Hello students, today we are going to do some previous year questions from the chapter Alkenes. So let's see the first question. Total number of isomeric compounds including stereoisomers formed by monochlorination of 2-methyl butane. So how to do this question? Let's see. So first we will draw the structure of 2-methyl butane. 2-methyl butane, you see, parent chain is butane, so there should be 4 carbon atoms, 1, 2, 3, 4. And at the second position there is methyl group, so this is CH3. So CH3, because carbon can form maximum 4 bonds, so accordingly we need to fill with hydrogen. CH2, CH3. So this is compound 2-methyl butane. So now the question, what is the question here? It is asked, this particular compound is treated with chlorine Cl2 H nu so that monochlorination happens. What is basically monochlorination? When you treat an alkane with Cl2 in presence of light or by heat, what will happen? This kind of bond breakage will happen, and what will happen? The R and the Cl group gets connected and HCl simply gets come out. Or the point is what? Hydrogen is now, you can see that it is replaced by chlorine. So how many chlorine atoms are there now? There is just one chlorination, so that is, it is called as monochlorination. So what is basically monochlorination? The meaning of monochlorination means the hydrogen atom in the alkene is being replaced by one chlorine atom. So they are asking how many isomers, you know, same molecular formula but different structures, like that, how many different types of compounds can be formed. So to do these kind of questions, we need to identify the different types of hydrogen in the given compound, because each type of hydrogen, when it is being replaced with chlorine, will give you a new compound. For example, you see in this given structure, you can see this CH3 and this CH3. There, if you see their connectivity, this carbon is connected with another CH, which is connected with CH2, CH3. If you look for this CH3 also connected with CH, CH2, CH3, same way. So which means the hydrogen atom of this carbon and this carbon is of same type. So I am marking it as type A or A type. Any problem? Similarly, if you see this particular hydrogen, it is unique compared to the other hydrogen, so I am marking it as B type. So let's take the other hydrogen present here, so that will be hydrogen C type, because they are different with respect to the other hydrogens. So you can see this particular hydrogen, this is also CH3, but I am not taking it as A type. Why? Because this hydrogen, if you see here, the carbon is connected with CH2, CH, but this CH3, if you see, it is connected with CH. So this CH3 and this CH3, they are different, able to understand. So I can mark this hydrogen of this CH3 as D type. So you can clearly understand that in this given compound, there are 4 types of hydrogen are there. So when I replace each type of these hydrogen with chlorine, I am going to get some compounds. So let's do that. So I already told you what is monochlorination. Monochlorination means hydrogen I am replacing with chlorine. So let's take, I am replacing the hydrogen, one of the hydrogen of the A type. So that what could be the product I can get? You see very carefully, the product is going to be CH2Cl, CH, CH3, CH2, CH3, right? This will be the compound because I replaced one of the hydrogen atom in the A type. Clear? So I got a new compound. How many chlorine atoms are there in that compound? Just one. So it is a monochlorinated product. Is that clear? Now let's see this compound. If you see, it has a chiral carbon. What is chiral carbon? If you ask me, chiral carbon means it has a carbon with all the 4 substituents are different. So in this carbon, if you see, one substituent is A, another substituent is B, another substituent is C, another is a D. So I will say this carbon is chiral. Chiral means it is what? Optically active. Optically active means what? It can rotate plane polarized light. And if you see in this compound, this particular carbon is what? Chiral. And you can see only one chiral carbon is there. That means this compound can exist as enantiomer. You know enantiomer, what are they? They are non-superimposable mirror images. Like if you take our hands, the right hand, this is my right hand, this is my left hand, they are mirror images to each other which I cannot superimpose. But this is superimposing, I can superimpose them. But what I am speaking, when I am taking enantiomers and I try to superimpose one over the other, it is not happening. So such kind of compounds or isomers which are non-superimposable mirror images of each other, they are called enantiomers. So if you see in this compound has only one chiral carbon. That means it is 100% optically active and it exists in two forms. One will rotate the light in clockwise and the other will rotate the light in anti-clockwise. Or what is the point I want to say, that the number of compounds or number of contributions from this particular structure will be 2. Able to understand? There will be 2 structure will be coming from this particular compound because this carbon is chiral. So this compound exists in 2 forms. I hope it is clear. Now I am going to replace the B type, one of the hydrogen of the B type. So what I will be getting, you see very carefully, CH3, one of the hydrogen of B type. That means that particular hydrogen I replaced by chlorine, so that I am getting CH2, CH3. So you see very carefully, is there any chiral carbon? No, because you see CH3, CH3, 2 substituents are same. So definitely there is no chiral carbon at all. So only one form from this compound. So the third means this is the third structure possible. Able to understand? First and 2 from the A type, third is from the B type. So let's see the C type. When we replace the C type, how many we can get? So I'm drawing that in the next page. So replacing the hydrogen of C type, see carefully, you see CH3, CH3, H, now you see CH, Cl, CH3, right. So I replaced one of the hydrogen of the C type, so I got this compound. Now also you can see that this particular compound contains one chiral carbon. That means it is optically active. It is going to exist as enantiomer. That means its compound has 2 forms. One will rotate the light in clockwise and the other will rotate the light in the anti-clockwise direction. Is this point clear? So the next number, it will be 4, 5 because this compound is existing in 2 forms. I think it is clear. Now I am going to replace the D type hydrogen. I am going to replace the D type hydrogen. What is that? Let's see D type hydrogen. So CH3, CH, CH3, CH2, CH2, Cl. So I replaced one of the hydrogen of D type and you can see that there is no chiral carbon. So it is going to exist in a single form and that will be the 6th form of that given monochlorinated compounds. So if you see, when I replaced each of the type of these hydrogen with chlorine, I am able to get 6 different compounds including the stereoisomers. Stereoisomers means optical isomers or even geometrical isomers. Conformational isomers we are not counting here because that will be infinite in number, right. So when we have seen that 1, 2, 3, 4, 5, 6. So the answer for this question is going to be 6. Answer for this question is what? 6. I hope this is clear, right. So let's move on to the next question. Number of alkanes obtained on electrolysis of a mixture of CH3COONA and C2H5COONA. So this question is based on a name reaction. What is that? Call-base electrolysis. What is that process? It is called call-base electrolysis. Basically, call-base electrolysis means we electrolyze a solution of a salt of monocarboxylic acid. What does it mean? For example, I am taking a solution of, suppose I am taking a solution of what? This is a solution of CH3COO. What is this? It is the sodium salt of acetic acid, right? So it is a salt of monocarboxylic acid I have taken. Any doubt is there? Now this we are connected with the platinum electrodes. This we are connected with the platinum electrode. Why platinum electrode? Because that is an inert electrode which is connected with the battery. Basically, electrolysis means what? We are going to do some reaction with the help of electricity. So electrical energy gets converted into the chemical energy. That is what basically it is going to happen here. So here the negative terminal connected. So negative terminal connected in electrolytic cell is cathode, and the positive terminal connected, that is the anode, right? So what are the process going to happen in this particular reaction? If you see very carefully, and you know very well what is anode. At anode what will happen? Oxidation takes place. At anode what will happen? Oxidation takes place. Yeah. Now if you see this solution, it basically, what are the components in this solution? If you see, it is CH3COO Na aqueous. Aqueous means waters. That means this will particularly dissociate into CH3COO minus plus Na plus. So the components in the solution, if you see, what are the different components in this solution? If you see, what are the components in this solution? If you see, what are they? There is acetate ion is there, CH3COO minus is there, Na plus is there, and H2O is there. These are the three different species present in this particular solution. So they are the species which is undergoing change when electricity is passed. And you can see very clearly in this particular reaction, CH3COO minus, it is going to undergo oxidation. That means oxidation, you know very well what is oxidation. Removal of electron is called oxidation. So what basically it is going to happen, you see very carefully, CH3COO minus. So CO minus means in this way the structure. So it will give out one of the electron outside, CH3CO, like this. So one electron came outside. So in the next step, this particular bond cleaves homolytically. Homolytically means the even breaking of a covalent bond, which leads to the formation of a free radical, CH3 dot, and here if you see, CO2 will be formed, because here one dot, here one dot, and the remaining electrons are there, and these two electrons simply combine to form CO2. So what basically we get here, CO2 comes out. So I'm just deleting the lone pairs. So you don't expect how those lone pairs, you have to just go through the chemical bonding chapter to get an understanding of that, or later in any other chemical bonding discussion I will let you know how many lone pair can come around an atom, right? So this is carbon dioxide just came out of this solution. I hope this is clear. So a methyl free radical happened. Any doubt? So let's take, there are two molecules of this, two molecules of this, two molecules of this, two molecules of this. Any doubt is there? So there is a two molecules of methyl free radical formed. What will happen? These two methyl free radicals, simply they just combine each other. They just combine each other to give you CH3. What is that? C2H6, or the ethane is formed. So what is the conclusion you can see in this particular reaction? At anode, what are the products formed at the anode? C2H6 plus carbon dioxide is formed in this particular reaction. I hope this much is clear for everybody. This much is clear? So I will just explain what is the process taking place at the cathode also, then I will come back to this question. So let's see the process happening at the cathode. Cathode, if you see, Na plus generally it is a spectator ion. Spectator ion means it is not going to have any change during the reaction. As you take in the reactant side and the product side, it is also going to be in the Na plus mostly. So Na plus has very less tendency to undergo reduction, so it will prefer to be in the Na plus state only. So who is the thing going to undergo reduction here? That is the one, H2O will undergo reduction here. So basically H2O will accept 2 electron. Reduction means what? Acceptance of electron, that is called reduction. It will change into OH minus plus H2. I need to balance this. So basically water gets converted into OH minus and hydrogen is released. Already in the solution, if you see, there are Na plus ions are there. So this 2 Na plus ions combines with this 2 OH minus to give you NaOH. So what are the products in the cathode if you ask me? What are the H2 and NaOH? This is the products in the cathode. So if I summarize this particular reaction happening for the given reaction, if I take CH3, 2 molecules of CH3COONA in presence of water undergo electrolysis to give you CH3 plus 2 molecules of carbon dioxide. Definitely there are 2 are there, so here also 2 I should add. 2 molecules of CO2 plus H2 plus 2 molecules of NaOH. This is the net reaction happening in the particular cold base electrolysis. So if you see H2 and NaOH, they are formed at the cathode. Questions will come like that also. CH3 and CO2, they formed at the anode. Is this much clear? Now let's take the given question. Now in the given question, not just the CH3COONA, along with that you have taken C2H5COONA, that is sodium propanoate is also taken. That means in the anodic step, not there is a probability of forming in the anodic step. That means in the given question, during the anodic step, if you take the 2 anion CH3COO minus and CH3CH2COO minus, if you see, there is a possibility of these kind of cleaving from the both side, from the acetate ion as well as from the propanoate ion. So means during the anodic reaction we can get a methyl free radical also, and there is a possibility of getting ethyl free radical. Right, these 2 possible free radicals can be formed in this particular question. Understanding? So the possibility is what? 2 CH3, they can combine each other to give you what? CH3, what is this? Ethane. Able to understand? What is the other possibility? CH3 dot and the CH3, they can combine to give you CH3, CH3, what is this? Propane. Now what is the possibility? 2 ethyl, they can combine each other, CH3CH2 dot plus CH3CH2 dot, they can combine each other to give you CH3CH2CH3. What is this? Butane. So they are simply asking how many alkanes can be obtained. So you can see very clearly how many alkanes we got: ethane, propane and butane. So the answer for this question is 3. What is the answer for this question? 3. The answer for this question is 3. I hope this is clear. Now let's go to the next question. A 100 ml solution of CH3CH2 MgBr on treatment with methanol produces 2.24 ml of a gas at STP. The weight of gas produced is dash milligram. So CH3CH2 MgBr. What is this? RMgBr. RMgBr, it is called as what? It is called as Grignard reagent. It is called Grignard reagent. See, basically Grignard reagent, if you see this R is R minus. This R minus can basically 2 jobs are there. One is it can act as a base, and it can another job, it can act as a nucleophile. It has basically 2 jobs are there, base and nucleophile. When it will be acting as a nucleophile, if you are treating this with a carbonyl RCHO, like the nucleophile means it will attack at a nucleophilic site, and this kind of shift will happen, RCO minus HR. So this later I will discuss in some other discussion of aldehydes ketones chapter PYQ. At that time I will discuss more how R minus is acting as a nucleophile. Currently I am just looking at the base, how this R minus is acting as a base. Base means what bases will do? Bases, they are good proton acceptors. What bases will do? They abstract. What base will do? They abstract acidic hydrogen. Basically what it will do? They will abstract acidic hydrogen. That is a simple job. So whenever we are reacting a Grignard reagent, if there is acidic hydrogen is there, it will take that first. Keep this in mind. So I am taking the compound as per the question, CH3, CH2, MgBr, which is reacting with CH3OH, methanol, which is given that it is reacting with methanol. Able to understand? So methanol, it is a you can see that methanol, it contains acidic hydrogen. You can see this is acidic hydrogen. So this CH3 CH2 minus, what it is going to do? It is going to abstract this acidic hydrogen. What it will do? It will abstract the acidic hydrogen, and what I am going to get? I am going to get CH3 plus Mg, remaining Mg contains Br, and the other thing OCH3 will contain. Or the simple point is what? CH3 CH2 was there, minus is there, it just came and has taken out the hydrogen from the methanol and it changed into CH3 and it contained O minus CH3, which just combined with the magnesium. So the product or the reaction, once again I will write what is the reaction. CH3 CH2 MgBr combines with CH3OH to give you CH3 plus MgBr and OH. OCH3, right? OCH3. That's what I have shown you. Now let's see, produces a gas. So you can very clearly see that this is the gas produced. What is the name of this gas? Ethane gas is produced. And the temperature condition given is what? What is the temperature condition given? STP. STP condition is given. So at STP, you know, 20 to 400 ml of gas contains 1 mole of substance. Means at STP, or 1 mole of any gas at STP occupies a volume of 22,400 ml. That means 1 mole of ethane. What is the weight of 1 mole of ethane? If I calculate CH3, what is the weight of 1 mole of ethane? How many carbon atoms are there? 2. So 2 into 12, 24. And the hydrogen, if you see how many hydrogen? 6. So 6 into 1, 6. Total 30. That means 1 mole of ethane gas which produced, means if it is 1 mole is produced, its weight is going to be 30 grams. And it is going to occupy how much volume? 22,400 ml. So that means at STP, 22,400 ml of ethane has a weight of 30 grams. Now the question, how much ml of this is produced? 2.24. That means 2.24 ml is going to have how much? That will be definitely 30 into 10 raised to minus 4 gram, because here you divided by 10 raised to 4. So the other side also I need to divide by 10 raised to minus 4 grams. So I need to convert this into milligram. You know very well how much 1 gram is equal to 1000 milligram. So I need to convert grams into milligrams. So I need to multiply by 10 raised to 3. So 10 into 10 raised to minus 4 into 10 raised to 3. This will be how much? 30 into 10 raised to minus 1, or nothing but 3 milligram. So the answer for this question is what? The answer for this question is 3. So basically before explaining the solution, I was explaining what basically the reaction happens there, because you should know how the reaction to be framed. So for that purpose, I just explained what are the reactions of Grignard reagent. Mainly 2 reactions for Grignard reagent. It can act as a base as well as a nucleophile. Base means it will abstract acidic hydrogen, and you can see in this particular compound, hydrogen connected with this oxygen is acidic. So this particular R minus, what is that R minus? CH3 CH2 minus is going to abstract this hydrogen and produces ethane. So if you see the balanced equation, the compound forms is what? Ethane is formed, and STP condition, that means 1 mole of that compound is going to occupy 22,400 ml. So that means 1 mole weight is 30 gram. 22,400 ml is having a weight of 30 gram. So 2.24 ml will be how much? And we calculated it as 3 gram. I hope this is clear. Yes, let's go to the next question. The total possible stereoisomers of dimethyl cyclopentane. The possible stereoisomers of dimethyl cyclopentane we need to identify. So basically cyclopentane, this is cyclopentane, right? This is cyclopentane. This is cyclopentane, and it is connected with the two methyl groups. So I'm just putting one CH3 here, one CH3. What are the different possible stereoisomers? Basically stereoisomers, what are basically stereoisomers they are asking here? What are the possible optical and geometrical possibilities? Because stereoisomers are classified into two, conformational and configurational. Conformational means that our eclipsed, staggered, they are infinite in number, but anyway that is not possible here due to ring constraint, we cannot rotate it. But the configurational means optical and geometrical. Optical means chirality, there will not be any plane of symmetry. Geometrical means, you know, restricted rotation, that I am not going into the detail of that, but still we will see what are the different possible stereoisomers we can draw for this given compound. So I am just taking at the 1,2 position, 1,2 position I am just taking. So what I am going to do, I am going to keep the 2 CH3 towards me, one possibility I have taken. So the question is this compound optically active? Is this compound optically active? Is this compound optically active? The compound is optically inactive due to a plane of symmetry. You may be thinking how plane of symmetry is possible. How plane of symmetry is possible? Let us take in another 2 positions. Let's take these 2 positions I will take, and I am going to draw a plane passing like this. So I can divide this equally into 2 halves. That means only one structure is possible from this given thing. But this is a cis form, right? This is a cis form. So that means I can draw a trans form of this. That means one CH3 upward and one CH3 downward. And you can clearly see that it does not have a plane of symmetry. So this transform is what? This particular transform is optically active. So this can exist as enantiomers. Enantiomers I explained in the first question. So there will be 2 forms of this particular compound. Is that clear? So I just tried a 1,2 position. Let's take another position. What is the another position I am going to try? Let's take the 1,3 position also. I am going to take the other 2 position. What is that position? I am going to take this position, 1,3 position. Okay, so I am just going to take the 1,3 position. 1,3 means 1, 2, 3. Okay, so let's draw that. So there also, for your understanding, I am taking these 2. That also 1, 2, 3 position only. So here the 2 CH3 are on the same side, and that is the cis, and I can easily get a plane of symmetry there. That means this is an optically inactive compound. So the 4th contribution is from this particular structure. Is that clear? Now if cis is there, there is a possibility of trans also. So I can make the 2 CH3 trans to each other. Trans means 180 degree opposite, and in this particular case I am not able to divide this into 2 equal halves. Or what is the conclusion I can say? This particular trans is optically active, so that is going to be the 5th and the 6th form. Okay, so even if suppose you are thinking why you are not taking this form, because that is also 1, 2, 3 only. So whatever the other structure you take, that will be the repetition of any of these structures which I have drawn. Now one doubt might be coming in your mind, why not 1, 1 position if I take? Why not this kind of a structure I am not taking? Yeah, of course this is an isomer, but it is not a stereoisomer of any of these structure. Why? Because this compound is neither optically active nor geometrically active, because it have a plane of symmetry. Definitely if you see, if I see CH3, one away from me, one towards me. So in this particular compound there is no, I can 100% divide this compound into 2 equal halves. So this compound is optically inactive. And the second is, I am not able to make any other geometrical isomers, because whatever the change CH3 and CH3, already both CH3, one CH3 towards me, another CH3 away from me. So I cannot make a new thing. For example, here if you see two CH3 are towards me, one I put behind me, means away from me, so I am getting the new. But in this particular case I am not able to get anything like that. So that means this is optically inactive. Also it is what, geometrically inactive. So we don't need to consider, because they are just asking only the stereoisomer. So this is not a stereoisomer. Able to understand? So the answer for this question, if you see how many stereoisomers I got just 6 stereoisomers. There is a very high chance that you may mark the answer 7 because of this one, but they are simply asking stereoisomers. So the answer for this question is 6. So I hope this is clear. So what I did, I just changed the position of the methyl groups and I just changed the stereo, means I just arranged the spatial arrangement. Once I tried both CH3 towards me and then one towards me, one away from me. And you may be thinking one doubt. Yes, I know. You may be thinking one doubt. Why, sir, you are not drawing this, right? You may be thinking why you are not drawing something like this, where 2 CH3 is away from me, away from you. I am saying that these two are equal. They are same. How they are same? You just take an axis like this, take an axis and rotate it 180 degree, you will get the first compound. So if I simply rotate, will the compound change? No. For example, you take me and you rotate me by 180 degree. Will I be a different person? I will be the same person, right? So like that, if I rotate this particular compound by 180 degree, I will get this compound. That means they are the same. Understanding? So here, but it is you will get two forms. What are they? If you say the mirror images, one will be like this and another one will be like this, but they are never same. You just rotate 180 degree, you cannot get the same. Able to understand? Yeah. Is it clear? So you cannot get the same. So they are different. So the answer for this question is 6. So if any doubt is there, you just let me know in the comment section. I will try to help you. So let's go to the next question. In the following structures, which one is having staggered conformation with maximum dihedral angle? Dihedral angle means this kind of bond angle. Means if there is a substituent X is there, this kind of substituent between the two carbon atoms, this kind of a bond angle. That is called a dihedral angle. For example, if I am drawing a particular structure like this, that means the bond angle between two different substituents in the adjacent carbon. For example, if you see this bond angle, if you see this particular bond angle, it is what? It is just 60 degree. Able to understand? That is just 60 degree. So if I take this C option and I draw the Newman projection of that, if I draw that, CH3 is there, H is there, H is there, and CH3 is there, H is there, H is there. So if you see, these two CH3 are almost, or you can see that they are 180 degree opposite to each other. They are 180 degree opposite to each other. Able to understand? So the maximum bond angle you can get it here because they are 180 degree opposite or anti-conformation. Able to understand? So here it is 60 degree, but here if you see, it is about 120 degree, like that. Here it is 0 degree because they are in the eclipsed form. Understanding? So in this way you can conclude the maximum dihedral angle is coming for the option C. I hope it is clear. Let's go to the next question. What is the next question? Excess of isobutane on reaction with Br2 in presence of light at 125 degrees Celsius gives which one of the following as the major product? So here as you see very clearly, excess of isobutane means we are reacting isobutane structure. You know very well what is the structure of isobutane. This is the structure of isobutane. We are reacting this with Br2 in presence of light at a temperature of around 125 degrees Celsius. So here they have given this as excess. Excess means if you take the alkane excess, the chance of getting mono-brominated product is the higher, because if you take bromine excess, what will happen? I have explained you in the first question. the bromine or the halogen will replace the hydrogens. So if the halogen is present in excess, it will replace all the hydrogen. So that is a problem. So to avoid such a case, what we will take? We will take the alkane in excess. So we will be getting the monobrominated product as the major one. Able to understand? So here, before proceeding, how to identify the major product in such a case of bromine, we need to know the reactivity of hydrogens. So if you see, the hydrogens are classified into three categories: tertiary hydrogen, secondary hydrogen, primary hydrogen. What is tertiary hydrogen? The hydrogen connected to a tertiary carbon. Tertiary carbon means carbon which is connected to three other carbon. So a hydrogen connected to a tertiary carbon. So this is a tertiary carbon. So hydrogen connected to a tertiary carbon. This is a tertiary hydrogen. Is this clear? Now what will be secondary hydrogen? A hydrogen connected to a secondary carbon. A hydrogen connected to a secondary carbon. Secondary carbon means connected with two other carbon atoms. So this is a secondary carbon. So these two hydrogens must be a secondary hydrogen. What will be primary hydrogen? A hydrogen connected to a primary carbon. For example, you see CH3, CH. So you can see that this is a primary carbon, and these all definitely, because this carbon is connected to only one another carbon, so they are the primary hydrogens. Clear? So the reactivity of these hydrogens in the bromination, if you see the reactivity of tertiary hydrogen, secondary hydrogen and primary hydrogen during a bromination, it is in the ratio of 1800 is to 82 is to 1. So this is the ratio. That means the rate of reaction of tertiary hydrogen is 1800 times faster than that of the primary hydrogen, or the rate of reaction of bromination with the secondary hydrogen is 82 times faster than that of the primary hydrogen. This way we have to interpret this. So let us identify what are the different types of hydrogen present in this given compound. So let's see CH3, 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 H is there. So you can see, definitely understand that this is a tertiary hydrogen, and because it is connected to a tertiary carbon. Tertiary carbon means what? It is connected with the three other carbon atom. Able to understand? Now if you see, there is 1, 2, 3 CH, CH3, CH3, H. Okay. So if you look at this carbon atom is a primary carbon atom. This is also a primary carbon atom. This is also a primary carbon atom. And definitely, because why it is a primary carbon atom? This carbon is connected with only one another carbon. This carbon is connected with only one another carbon. This carbon is also connected with only one another carbon. So definitely all these other hydrogens are what? Primary hydrogen. Able to understand? So definitely if you see the reactivity of tertiary hydrogen is 1800 times than that of a primary hydrogen. So definitely out of these 3, 6, 9 primary hydrogen, it is just going to prefer this only one tertiary hydrogen, because the rate of reaction is this much times faster or more preferred with the tertiary hydrogen. So what will be the reaction? The bromine will simply replace one of the tertiary hydrogen, CH3, CH3, and what you will get? You will get Br here. Able to understand? This must be the product. But remember, in the case of chlorine, this reactivity is not that much different between tertiary and primary. The order is going to be 1 is to 3.8 is to 5. So in that case, there are some calculation is there. We need to identify which is the major product. So that you can see in another section which I will be taking later. So the point is what? Bromine we can easily say with tertiary hydrogen without much calculation, because the reactivity is much differ compared to the other, because 1800 is much higher than 1. But in the case of chlorine it is 5, 3.81. They are much they are not that much difference is there. So we have to do one simple calculation method is there. So anyway, so if you just look at this question, what will be the answer of this question? The answer of this question will be D. Right? Why not C? Because monochlorination is the answer, because here also if you see the CaBr is replaced at the tertiary hydrogen, but that is not the answer, because they are asking for monochlorinated product. I hope this is clear. Any doubt is there? Now let's go to another question which is asked in a JEE Advanced 2019 question. Still now we have discussed the JEE mains questions. So one advanced question. This is the pattern we are right now following. So much mains question and one advanced question, because as mains is coming near, so we are focusing more on mains, and later we will focus more for advanced. Now those who are preparing for advanced along with the mains, this let them also benefited. So I'm just adding one advanced question also. They are asking which of the following is going to produce propane as a major product. It has been asked on 2019 advanced paper. So the first question is reacting with soda lime or heating with soda lime. What is the first thing? NaOH plus CO. What is this? This is soda lime. So heating with soda lime, heating with the soda lime, what basically will happen? If I take CH3, CH2, CH2, COO, Na, this basically will change into CH3, CH2, CH2, COO minus plus Na plus. Now upon heating, what will happen? This will simply release as CO2, and what I will be getting? CH3, CH2 minus plus CO2 is produced. Able to understand? Now in the next step, this is in an aqueous solution. So CH3, CH2 minus, what it will do? It will abstract an acidic hydrogen from the solution like this, so that it will give you CH3, CH2, CH3. What is this? This is the propane. That means from option A, I am going to get the answer propane. So it is a multi-correct. They are asking produce or produces, one or more type question. So anyway, option A is correct. Now let's see option B. Option B, you can very clearly see in the beginning of this chapter, in this discussion, second question I have discussed the call-based electrolysis. You can clearly understand that this is call-based electrolysis. So you can see the free radical produced from this question is going to be CH3, CH2, CH2 dot. Definitely it will combine with another molecule of CH2, CH3 to produce what? It produce hexane. So option B is not the answer. Now option C, if you see, zinc dilute HCl, it's a reducing agent. Basically this Cl will be replaced by hydrogen. It's a reducing agent for alkyl halides. So if you react Rx with a zinc dilute HCl, the product is going to be RH. So similar way, if you apply here, you will get CH3, CH2, CH3. So this particular C option also gives you propane. Now the last option, it is vicinal dihalide. Vicinal dihalide, if you treat it with zinc, what will happen? You will get something like this and zinc Br2. That means you are getting a propene, not propane. So the answer for this question is option A and option C. So from all this discussion, you have come to know that this alkanes topic is very important for the JEE main as well as for the JEE advanced. And I like to remind you, there are some reactions particularly given in NCERT like isomerization, aromatization, those kind of reaction. You must go through the NCERT. Direct questions are also being asked. And another important topic from this alkane is the IUPAC nomenclature. So you just need to do that as well for the JEE main and for the JEE advanced. So I hope this discussion you find fruitful, and I'm hoping that all this series is helping you. So you kindly share this with your friends and whoever is the well-wisher of this channel, and to support this channel, please do that. And you can comment your valuable feedback and valuable your support. You can show your love in the comment section. So all the best, all the very best students, and we will see with another topic soon. Take care. Bye bye.